Hi, I'm Lauren, and the problem that I'm doing today is number 34. A soccer player kicks a rock horizontally off a 40-meter high cliff into a pool of water. If the player hears the sound of the splash 3 seconds later, what was the initial speed given to the rock? Assume the speed of sound in air to be 343 meters per second. So first I drew a diagram. This is a soccer player, this is the rock, and where the rock is kicked horizontally is going to be my 0. This is the positive x direction, the positive y direction, and we know that the height of the cliff is 40 meters. We also know that the path that the rock takes approximately is kind of an arc, and it splashes here in the water. And the 3 seconds is not the time that it takes to just splash, but the time that it takes to splash and the sound to travel back up. So this is my givens. My given is that in the x direction, we only know that the acceleration is 0 meters per second initially. This means that we're going to have to solve for the time via the y direction. So for the givens in the y, we know that the initial velocity is 0 meters per second. The acceleration is 9.8 meters per second squared, and the displacement is 40 meters. That's the height of the cliff. So I want to solve for time, and I could have done it directly using a quadratic, but I didn't really want to, so I first used the final velocity. So I solved for final velocity, which I used this simple kinematic, and I got final velocity equals 28 meters per second. So armed with that, I can now solve for time. So time, using this first kinematic, I solved was 2.86 seconds. So that's the time for the y direction, but that's also the time in the x direction because the times are the same. However, that's the time that it takes for this path, this dotted path. But what we know is that this dotted path plus this time back to the person's ear is 3 seconds, meaning that the difference of this is 0.14 seconds. So the time that it took to travel this line is 0.14 seconds. And we know that since the speed of the sound in air is 343 meters per second, I multiplied the two so that this distance in meters is 48.02 meters. Now we can use this and we can Pythag it. So we know that this is 40 meters, we know that this is 48.02 meters, and we're trying to solve for the distance from the cliff to the splash. So I did some Pythagorean and I found 26.57 meters. That's this direction, or this distance. So if this distance is 26.57 meters, and we know that this time is 2.86 seconds, then just distance over time equals rate. We know that the speed traveling in the x direction is 9.29 meters per second. And since there's no acceleration, as we was given before, we know that the initial speed of the rock was also 9.29 meters per second.